Okay, we're going to start chapter 5. The first section deals with the fundamental identities. Technically, there should be nothing new in this section other than the negative angle identities. You've never seen those before. We're going to review all of those old identities, including reciprocal identities, Pythagorean identities, quotient identities. We'll add the negative angle identities in with this, and we'll do some weird stuff that you've never really done before. It's a strange section. It seems to have no point, but its goal is to prepare you for the rest of chapter 5. So we're going to build on some skills that you're going to need to get through chapter 5. You are going to be asked to use these identities instead of going back to the definitions and drawing the triangle. So be very cautious and read directions very carefully for this unit. Okay, so real quick, let's review your reciprocal and your quotient identities. The reciprocal identities state that cotangent of theta is the same as 1 over tangent of an angle. Right. So as long as your angles are the same, the cotangent value is always equal to 1 over the tangent value because they are reciprocals. It would also be true vice versa. Tangent is equal to 1 over cotangent. I assume that if you know one, you know the other, but if you need to write all 6 down, please do that. We know that secant of theta is equal to 1 over cosine of theta, and likewise, cosine of theta would be equal to 1 over secant of theta, right? And finally, cosecant of theta is equal to 1 over sine theta, or sine theta is equal to 1 over cosecant of theta. Those are your 6 reciprocal identities. If you know 3, we assume that you know you can just switch the place of the trig functions and know the other as well. The quotient identities state that tangent of any angle is always equal to sine of that angle divided by cosine of that angle. And that is only true if the angles are the same, so be very careful with that. Cotangent of theta is equal to cosine of theta over sine of theta. So I'll pause for a second and see if you need to make some notes there. Hopefully you know all of these. Other than reciprocal and quotient identities, you really need to know the Pythagorean identities. And you're going to need to know those from now until the end of this class, and we even use those in calculus. So if you're headed for calculus, the reciprocal, the quotient, and the Pythagorean are things you are going to be expected to know from here on out. You're going to have to understand them and know how to use them. Okay? The negative angle identities here, they're not as important, but your book does kind of make a big deal out of them in this section. So you are expected to know them, and you will have a memory quiz on all of these things. The reciprocal, the quotient, Pythagorean, and negative angle. So we will have a memory quiz on that very, very soon, as in like the day we review for your test. Okay, so and what I'll do is I'll give you the memory quiz, and I'll grade it, and then I'll let you use it on your test, like after it's corrected. So at least you'll already have it all written out. And I think that works best so you can kind of look at them. But you will have a quiz on it first. So make sure you go ahead and memorize this because that will be on the review day. And then you'll be able to use the corrected version on your test. So at least you'll have it all laid out for you. Okay, let's just make sure we talk through these. The Pythagorean identities state that sine of any angle, and then you square it, plus cosine of any angle, and then squared, always equals 1. 1 plus tangent of an angle, and then squared, always equals secant of the angle, and then that quantity squared. Notice that they put the square in a funny place. We talked about that before, but it really means the entire sine of the angle and then squared. And finally, 1 plus cotangent of an angle, and then squared, is equal to cosecant squared of that angle. Make sense? Okay, now the negative angle identities, they're a little weirder. I'm not real fond of them, but like I said, your book does expect you to be able to use them. What they say is if you take any of the trig functions of a negative angle, well, let's say I take 30 and negative 30. Positive 30 would be in quadrant 1, 30 degrees, but negative 30 degrees would be in quadrant 4, right? Well, do those have the same sign, or are they opposites? They're opposites. In quadrant 1 and 4, in 1 sign is positive, but in 4 sign is negative, so they're opposites. And that's what this identity right here is telling you, that if I move an angle into the 4th quadrant and it becomes a negative angle, it will have the opposite sign of that angle in the 1st quadrant. And that's true for all 6 of them are equal to their opposites, except for which one is positive in both quadrant 1 and 4? Cosine and secant, right? They're positive in both places. That's why these two right here are the same. Whether that angle is in quadrant 4 or 1, they're both positive. In quadrant 4, that would be positive, and in quadrant 1, that would be positive as well. All 4 of the others are negative in the 4th quadrant and produce the opposite effect than when that angle is in the 1st quadrant. Another thing, what are the only 2 of these trig functions that when we graph them have y-axis symmetry? Cosine and secant. So you can see it there as well. They don't have the opposite. When you move over into the negatives, they behave exactly the same as they did in the positive direction. So you can see that kind of symmetry showing up in these identities. Do you have any questions about these? More than anything, you just need to memorize them. Got it? You sure? Okay. Let's see what we have for our first. Well, I wanted to do an example. Let's see what this says. Remember that in trigonometric identities, the angle theta can either be in degrees, a real number, or a variable. So what's a real number? A real number is another way of saying radians. So you don't know unless you're told whether it's in degrees, radians, or most of the time it'll just give you a variable. Your book is just pointing out that it doesn't matter what the angle is, these identities still hold true. Whether it's in degrees, whether it's in radians, or whether it's left as a variable. So that's all your book's trying to point out there. Here's our first real example. We are given that tangent of an angle theta equals -5/3, and we know the angle is in quadrant 2. We would like to find the function value of secant instead. So let's pause for a second and give everybody a moment to kind of wrap their brains around it and see if they can start thinking of a way to come up with this without drawing a triangle and using the definitions. We're going to have to use identities here. Okay, so let's see about working through this. First off, we need to recognize, what do we know? We know one trig function. Which is it? Tangent. All right, well, immediately that limits the identities we can use. If I know tangent and I'm trying to find secant, there is one identity that involves them both. Which is it? Which one? Say it. 1 plus tangent squared equals secant squared. That is the only identity that has tangent and secant as its only 2 trig functions. So then when you look at the list and you study those, you try to look for one. The best case scenario is if you have exactly the 2 you're interested in. I'm interested in tangent and secant. And so for that Pythagorean identity, we know that 1 plus tangent squared of the angle always equals secant squared of the angle. So that has exactly what I need. Now, some others have tangent in them, but they don't have secant. Make sense? Okay, so you want one that has the 2 you are dealing with, the one you know, the one you don't know. That's not always a straight shot. Sometimes we have to go through one to get to another and then another, which kind of is a pain. But this time it's a straight shot, a direct connection. And all you do is substitute in what you know and solve for what you don't. So if I substitute in -5/3 for tangent of theta, be sure you put the square on the outside. The square will always go on the outside of the parenthesis once you substitute. That has to equal the value of the secant, but squared. Then you just perform the computations. If you square that, we have 1 plus 25 over 9 has to equal secant squared. And 1 plus 25 over 9 is 34 over 9. You should be able to do that right now. Do y'all know how to add 1 to something? Yeah, add the bottom to the top. Works every time. If you want to add 1 to something, to a fraction, you add the bottom to the top. 25 plus 9 is 34, and you keep the bottom. That's what secant equals. Well, secant squared. I want to know what plane secant equals. How do we get rid of a square in algebra? You square root both sides. So if we square root both sides of this equation, we know that secant of the angle must equal, and when you do the square root of both sides, you have to do plus or minus, the square root of 34 ninths. Well, that has to be cleaned up. The square root of 34 over the square root of 9. So that ends up giving me plus or minus the square root of 34 over 3. That's what secant equals. You can't leave both plus and minus. You need to narrow it down. But I give you information about the quadrant so that you can figure out whether that's positive or negative. It says that the angle is in quadrant 2. Well, in quadrant 2, we know that sine and cosecant are positive. Secant would be negative. And so at the very, very end, you use the quadrant information to choose whether it's positive or negative. Square root of 34 will not simplify, but the square root of 9 reduced down to 3. And that is how you use a Pythagorean identity to find a missing trig function value. Now this is a continuation of the same problem. Given what we already know and what we've already found, we would now like to use it to find sine of theta. So let's talk a little bit about what we knew. You were given that tangent of theta equaled what? Negative 5 over 3. We just found that secant of theta equals negative square root of 34 over 3. And now somehow we would like to find sine. Oh, we also know one other thing. We know what quadrant it's in. What quadrant? 2. All right, so that's all we know, and we want to use that information to find the missing value of sine. Okay, is there a direct link between tangent and sine? There is a link. We know that tangent equals what? So we do know that tangent equals sine over cosine. But that's not direct, because in order to find that, I would also need to know the value of cosine. But that is one option, right? Okay, so that's one option. Another option would be this. If I know secant, do I also know cosine? Think about it. I do. If I flip it, I know that cosine is equal to negative 3 over the square root of 34. Does that make sense? Okay. So technically, and I'm not going to rationalize that until the very end. That's not my final answer, so there's really no sense in us rationalizing that right now. Now that I know cosine, I could either substitute into tangent equals sine over cosine, because I know 2 of the 3, or I could substitute into this guy. Sine squared plus cosine squared equals 1. Both of those will give you the exact same answer. I prefer to plug into sine squared plus cosine squared simply because it won't involve me dividing a bunch of fractions. Is that okay? All right. So sometimes what you have may not be a direct link, but if you look at some of the reciprocals, because if you know one, you always know the reciprocal, then you might find the direct link between what you have and what you hope to find. So now I'm going to use this formula, sine squared plus cosine squared equals 1. I'm going to substitute in the cosine and solve for the sine. So we know that sine squared plus negative 3 over the square root of 34 squared has to equal 1, which means that sine squared plus 9 over 34, when you square a negative, what happens? It becomes positive. So sine squared plus 9 over 34 has to equal 1. And then we're going to subtract 9 over 34 from both sides, which means that sine squared of an angle must equal, what's 1 minus 9 over 34?
25 over 34.
25 over 34, yeah. So 25 over 34. And then we're going to take the square root of both sides. So it looks like the sine of the missing angle is equal to plus or minus, split up the top and bottom, 5 over, and square root of 34 doesn't simplify, so we'll leave it as square root of 34. And we have to do 2 things. This will be our final answer if we can just do these 2 things. We have to decide if it's positive or negative, and in quadrant 2, the sign is positive, yeah. Australian swampmen trained crocodiles? Yeah. So it's positive 5 over the square root of 34. But the second thing is we cannot, for our final answer, leave a square root in the bottom, so we have to rationalize. So we'll multiply top and bottom by the square root of 34. And that will equal 5 square roots of 34, all divided by 34. Okay, so that takes a long time. It's a lot of logic, it's a lot of building. And I know that it seems kind of pointless, but the skills that you're building here and connecting the topics, they actually really are good for helping your brain get ready for like things like the LSAT and the MCAT and some of those, you know, the GRE, which is like what you have to take to get into graduate school. So for some of you who are moving on after college to higher levels there, these really are good for you, even though they seem pointless. Does anybody need a moment on this? There's still a third part to this problem, so let's look at it. The third part to this problem asks you to find the cotangent of negative theta. So now that we know the tangent, we know a bunch of them. We know tangent, we know sine, we know cosine, and we know secant. But we would like to find the cotangent of negative theta. Now, the quickest way to find cotangent is if you know tangent, you simply flip it upside down, right? Yes. Okay, so let's take a look at that one. We know the tangent of theta is equal to the reciprocal of cotangent, right? Okay, so what was tangent? Negative 3 over 5? Negative 5 over 3? Okay, so that's what we started with. If that's tangent, then cotangent has to be negative 3 over 5. Now, am I asking you for cotangent of plane theta? No. Okay. Well, we know from the identity the cotangent of plane theta is equal to the opposite of the cotangent of negative theta, right? They're not equal, they're opposite. So it's the opposite of the cotangent of negative theta. Doesn't matter which side you put the negative on. So that's one of your negative angle identities. So that means that if this is cotangent of plane theta, cotangent of negative theta has to equal negative 3/5, right? So it's actually going to end up being, that's a weird 3. Let's fix that. So it's the opposite of this guy. So the opposite of negative 3/5 is positive 3/5. Did that make sense? Okay, one more time. We knew tangent, and if we know tangent, we can just take the reciprocal and find cotangent. And that gave us cotangent of plane theta, right? Cotangent of plane theta was negative 3/5. Well, the cotangent of negative theta is the opposite of the cotangent of positive theta. So we simply change the sign to positive 3/5. That wraps up example 1. Most of your homework is going to deal with those sorts of things, so you're really going to have to kind of try to find the connections there.